What's up, guys? So as you can see, the FM Towns is once again gutted and torn apart, and the reason for that is right here, good old power supply. So after spending a lot of time and effort to repair this thing a couple of years back, it did work for a short while, and then I didn't really use this machine for a very long time. And then when I came back to it, I think I turned it on and the CD drive wouldn't work. So I turned it off and then I left it alone for a very long time because I didn't really feel like dealing with that. Then at some point I came back to it, turned it on, and it wouldn't turn on. So this time the power supply had died. What a waste of effort. So, in for a penny, in for a pound. So I've decided, in a collaboration effort with another person that I met over on some forum, to kind of try and come up with a drop-in replacement for this power supply. Now there are someone on a FM Towns forum that is doing the same thing. He has done it with the desktops. This is a tower model, the 20F, and I think he's working on doing it for the towers as well. His design is based around the Pico PSU, and his design is kind of an expensive one. Me and the other guy, another guy, we are going to be attempting to make our own based around the Traco power modules, which is the same thing he used for the drop-in power supply replacement of the Marty here, which I made use of a while back. Okay, forget what I just said. It's been quite a while, a couple of years. A bunch of things happened. So the collaboration I was talking about in the previous segment, that didn't happen. The guy, I think he just lost interest. He stopped replying. And right around the same time, some other guy started making a project for power supplies for the FM Towns tower computers specifically. So if I wanted, I could have just gone with his solution, and I wouldn't really need to do much, just buy the parts, get the PCB printed and stuff. The thing is, I had reservations about, I just didn't, there were some aspects of it I didn't really, they were not to my taste. But for most people, and like 99% of people, it was perfectly fine. So I didn't want to do that, and I didn't want to do my own all the way from scratch. So also I didn't really need it because I already had a working FM Towns. I didn't need to have the tower actually working. It's just in storage. So it just was put on the back burner. So recently, for whatever reason, I was inspired to go back to it. And the thing is, so the guy that made the tower power supplies for the FM Towns, he actually put out the plans, so you could just get the parts yourself, which was great of him. So what I did was I downloaded his plans, and I decided, why don't I just make some changes to make it more to my taste. So yeah, let me just take this off and we can just go through some of the stuff I did. Yeah, so the guy is Cytoville. I think if you look for this FM Towns power supply Cytoville, you will find the project page on GitHub. Yeah, and then you just download it and you'll read through to find out what kind of parts you need, etc., etc. So to go back to how the FM Towns Marty power supply was handled by the other guy, what he did was that he had these modules, like they just take AC in and they put out the voltage. They're like this neat little square little things, and he had 3 of those, one for a positive voltage, a negative voltage. I think it was 9, +9, -9, and +5. So, and those were the voltages required by the FM Towns Marty. Those were very neat. I really like that idea. The thing about those modules is that they're kind of expensive. And the thing about the tower FM Towns is that their power requirements are higher. And also they're not really known in terms of like the different voltages. So this whole thing by itself, I think is it 80 watts or 90 watts? Something around there. So the maximum power draw of this is stated on the machine itself to be around that let's say 100 watts max, something around in that ballpark. But you don't really know how that breaks down in terms of the voltages that this power supply puts out, because it puts out it puts out plus 12, minus 12, and 5. Now, if I were to guess, the minus 12 is likely to be the least demanding of those, because usually minus 12 is usually used for audio circuitry and stuff like this. I'm not sure why audio usually, at least in older machines, requires a negative voltage, but it does. But I don't think it's very power hungry. So the next question is, so what are the power requirements of the plus 12 and 5 specifically? And this is not known. So what the other guy, the guy that made this Cytoville, what he did was he used a Pico PSU. So Pico PSU is this little thing, this little doohickey, which is designed to go on an ATX motherboard into the appropriate connector. And what it does is that it takes the 12 volt input and it outputs a variety of voltages. So it puts out the 5, minus 12, yeah, and also plus 3.3. But that's not really relevant for us because the FM Towns doesn't really use 3 volts. So what we need from this, also it has this neat feature where it has a standby mode. So once you put this in and you feed it 12 volts from one of these connectors here, it's in standby mode until you you kind of bridge, and it outputs 12 volt on one of these pins. I think one of the middle ones here. And once that goes to ground momentarily, it kind of like springs to life. That's a signal for it to actually start powering on. So the neat thing the guy did was that he incorporated that into like the soft power capabilities of the FM Towns. At least for in my case, it's the 20F, the 20F tower. So the way the 20F works is that it has 2 different ways of turning it on and off. I think they come from this. I think they come from these 2 pins here. So yeah, so once one of these 2 is connected to ground, that's the signal for the power status of the FM Towns to change. And one of them comes from the button on the front of the machine. So if you press that down, it momentarily connects one of these to ground, and that's the signal for the power supply to turn on or turn off. So it's kind of a flip-flop. And the other one is actually controlled by the OS itself. That's the OS power. So once you go into FM Towns OS and you choose shutdown, once it's done doing all the stuff and like it's ready to turn off the machine, it just sends that signal. So the guy had both of these, the functionality of these 2. He kind of like figured out how that works. And that was also one of the reasons why I didn't want to do it myself, is because I don't have a functioning power supply. So I couldn't even figure out how those 2 things are supposed to work like in a working machine. And I tried to ask the guy that did this a couple of times to explain to me exactly how that works. And he didn't really ever give me a clear answer. But I figured it out in the end by looking at the code he used, because the way he actually implemented this is that he had this little chip here, an Arduino. In his version of this, you have an Arduino Nano or Micro, I forget. Anyway, it's one of those smaller Arduinos. It's kind of a tiny little computer. It can do a lot of stuff, and it has a lot of input-output pins. So he just used 2 of those pins, both connected to these, and he wrote a little bit of code that said, okay, so once one of these goes to ground, just change the power status, and that did outputs to the pin on this little thing here and tells it turn on or turn off. Pretty neat. But I didn't really like the Pico PSU thing, because first of all, this doesn't really work by itself. You need to feed a 12 volt. So what he had this little power supply, this big one you can buy. And what that does is that it just takes AC in and it outputs 12 volt to this, and then this does the rest. And the power supply he was using was kind of a beefy one, so it had plenty of headroom. And I think the Pico PSU he was recommending is the one that I think it can do 120 volts or something, or way more than this technically would need. But the thing is, the Pico PSU is actually, even though it's like the wattage is pretty high, what it actually outputs on the different pins, it varies. You can go into the specifications and read that. The minus 12 volts specifically has a very low amperage output. I don't know if that's enough. I don't know if the 5 volts and the 12 volts are enough. Anyway, that's just the way things are with this thing. So, but it seems to be working for other people. So I thought, I don't want to do the 3, or actually I wanted to do the 3 different modules, just like the FM Towns Marty power supply. Unfortunately, I had to give that up because when I looked up what it would cost to get the 3 different ones, actually I couldn't even get just 3. I think I would need more than 3 to do the entire thing, because I would need 1, or maybe what I could have done was I could have done a small one with low voltage just to power the Pico PSU power on-off little circuit, and then the other ones would just be turned on by once the power was on, those other ones would spring to life. Anyway, at the very least, the 12 volts and the 5 volts would have to be pretty beefy, and like to get the wattage that I would feel would be sufficient, even though I had no idea what the 12 volts and 5 volts are, it would be pretty expensive. So this thing would end up costing, I don't know, hundreds of dollars. And I thought, no, maybe I shouldn't do that. So I thought, okay, I'll just modify the Pico PSU thing, because I found out that the those little module things, actually there's another manufacturer that does those. Look at this thing. This is just like those. It takes in a AC from these beefy pins, and it outputs 12 volt DC here. So yeah, so I could power everything off basically from this, which would go to this, and this would provide all the other voltages. And this one just looked neater than the one that this one was designed for, because that one is like not a self-contained. Actually, it is a self-contained, but it's not in an enclosure and everything. It just looked neater, and it's actually pretty cheap. I forget how much, but this is relatively affordable. So I designed it to kind of go into these holes here, and also the thing about the way this is designed. Let me turn this to the correct orientation. Yeah, so the power comes in from here. The way it's designed is that it has a little relay here. So you can see it has power in from here, and it has power out. So the way it works is that once the actual power supply comes to life, this relay gets a signal and kicks into a gear, and power actually starts going out of this one. And this one is kind of like designed for, if you have a monitor, you can just put it in here, and once the machine turns on, your monitor will come to life automatically. Pretty neat. Now, it's not really relevant for me, to be honest, because I'm not going to power a monitor off of this. And also, this solution I'm doing here is going to be 220 volt compatible. So I'm probably just going to run this directly off of the wall. In which case, this actually should not be used, because then this would be putting out 220, whereas like, I mean, this is a 100 volt connector, so it would actually be dangerous to put a monitor designed for that kind of voltages and feed it 220 volts. So I thought, okay, I kind of want to implement this just for fun, but I want to be able to disable it too. So I designed it so that I could take off, let me see, what is it? Yeah, there's this little jumper here. I don't know what it's actually used for on this thing, but I'll just solve this off and put it in here, and depending on where you move it, it will enable or disable the relay. Also, I wanted the fuse to be a part of my little design, so I incorporated that. I took these filter caps here, and I incorporated those as well. Not really, probably not needed. In fact, I'm fairly certain that it's not, because all the other stuff is probably already going to have. I'm pretty sure this has filter caps and all this sorts of stuff in it. I can see that this one also has that, so it doesn't really need it, but I just wanted to do it anyway. Why? For fun. Also, I noticed that the little mounting holes here that he had, they were actually, I printed this out on paper, and I just lined it up with this thing, just to see if things were lining up. Also with this, and the holes were off. So I printed out like, I think a dozen different versions where I just moved things around a little bit until I got it more or less perfect. Now this one fits perfectly. So that was another fix. Did I do anything else? Yeah, no, other than like this, the relay, the fuse. Yeah, that's pretty much it, I think. Oh yeah, one more thing. So I really didn't like the fact that he was using an Arduino, because the Arduino is kind of it's super overkill for the kind of functionality that this power on logic circuit is. So I was playing around with the idea of, why don't I just implement this using like discrete logic chips, like AND gates and stuff, or a flip-flop or something like this. And I started reading into like how I'm supposed to do that, and I discovered, oh, then I need a debounce circuit, because like once you have these hooked up to something that like a button or something, the thing is that like, even though to us logically it seems like when you press the button and you let go, it's just a binary thing. Actually, in the circuit, what happens is that it kind of like bounces, and so you have to soften that out. So it just became, yeah, I was way over my head there. So I thought, why don't I keep the idea of using a kind of a off-the-shelf processor thing to do this, but change it to the smallest variety, the simplest thing I can get. So I found out the code he had written, the Arduino code, is actually also compatible with these parts called ATtinies, and there is an ATtiny that only has like, it only has 4 pins, and I need 3, so that's like as close as I can get. And also like the Arduino he was using, it's kind of a proper computer. It's almost, I think I was looking it up, don't quote me on this, but some of those things, even though they're very small, it's in a very powerful microprocessor in there, and it's kind of like, at some point, especially the people who use like pies for this kind of stuff, that's completely overkill, because the pies themselves are a complete self-contained computer, and what you could actually, I'm pretty sure you could emulate an entire FM towns on those pies. I'm not sure about the Arduino, but yeah, I'm more or less certain that like at least from the processor point of view, the processor inside the FM towns and the processor inside this are probably not that far from each other. Whereas this one is just contained to just listening to like a signal coming in and putting a tiny signal out, a binary thing. It just seems super overkill. So it just bothered me. I wanted to have something a lot more appropriate in terms of functionality. So the thing about the Arduino thing, the advantage there was that it has a USB thing inside, so you can just program it, but the ATtiny doesn't. So I had to get this thing, this project thing. It's a ATtiny on a USB board, so you can actually program it. I'm actually not sure if this works. I need some specific software that only runs on Windows. So, and I don't have any Windows machines because I'm a Mac guy. So I need to figure that out somehow. But I already rewrote the code. I mean, all I needed to do was to change the inputs and outputs, and then make sure that once you put the chip down, the traces go to the right things, and you change the paths. So I did all that, and I added a resistor and a capacitor as per like guidelines for when you power the ATtiny. You should do this. Yeah. So I'm basically ready. I have all the parts, as you can see. I also have this like ATX thing. The thing is, I made a kind of a big mistake. Not big, kind of a stupid mistake. So this one is yeah, it's 24 pin, and so I was looking for the correct Pico PSU with a 24 pin. I found the one. It had a effect of about 80 watts. This one can put out around 90, so they were a perfect match for each other. A little bit low maybe for this, but it might have worked. But then I found this, which was actually much cheaper, a Pico PSU, and it's 120 volt. It's kind of a refurbished one, so it's kind of used, but who cares, right? I'm not going to use this thing enough that it matters. But what I neglected to actually take a look at was that this actually has 4 pins fewer than the 24. It's a 20 pin one, and this could have been a disaster because I mean, it has fewer pins. How is that supposed to work? But the thing is, it actually does work. It's just like these 4 last pins, either to this side or to this side, they're just not on this thing, but you don't need it. Those are just replicates of some other pins. So you can just put this all the way to the one side and put it in, and it will work. The other pins are like, yeah, they're a match. So I got lucky there, but these things always happen to me. I just research too many things, and then suddenly I decide, now I'm going to go buy everything, and I usually make a stupid mistake like that. But yeah, I got all the parts. All I need to do now is to figure out how do I program the ATtiny. Then I'm going to hope to God that all of these holes that I measured out and placed down, that they're all correct, and I got all the traces correct as well. There's no guarantee. The thing is, getting this printed was actually quite expensive. The last time I did something like this, it was a tiny board, and it actually makes a huge difference in price, the size apparently. So this one, much more expensive than I was expecting. I wasn't expecting like this, the size to matter this much, but you know, in hindsight, it actually makes sense. So I really do not want to have to get another set printed. That would be a very expensive mistake. So hopefully all this will work. Well, let me just put it all together and I'll get back to you. All right, so here we are, the almost finished product. Everything's more or less in place now. As you can see, the voltage out is inserted and the functionality is enabled through this little thing that I lifted off, the original. I have these capacitors and the little fuse and one more capacitor. I'm fairly certain that these are like completely superfluous. In fact, yeah, I'm pretty much 100% sure that if I just leave these off, nothing will change and it will work as well as it would otherwise. Yeah, so the port that goes into the FM towns is here. This is the main or the secondary voltage producer that takes the 12 volts in that comes out of this thing, and then it outputs all the correct voltages to here and handles the soft power on off via the ATtiny, which I am yet to solder in here. And the reason why I haven't put the ATtiny in is because I have to figure out a way to program it first. As I said, it requires a Windows program, and I don't have access to a Windows computer because I don't use Windows. I kind of like, yeah, I really hate Windows. It's a really shitty operating system. For work and stuff, I vastly prefer Macintosh. I also don't really care too much for Linux. Yeah, so yeah, this is just about ready to go. So you can see it looks very nice. Lots of like lots of empty room. All the connectors are where they're supposed to be. And yeah, I just need to just for sanity's sake, verify that these capacitors are actually placed in the same manner, because the thing about these two is that they go from the primary to the secondary. I guess it's to provide a little bit of voltage to the secondary if there's a spike or something. Don't know. It's a bit of a mystery to me. This one is just completely in the primary, so this just smooths out the AC voltage coming in. This, I think, is to smooth out the the DC voltage. Odd, but it is what it is. Uh, is it for that? Actually, I'm not sure. Maybe, because the thing is, this old one here, when you plug it in, it has to provide a little bit of a voltage to turn on the circuitry that actually detects when you press the power button on the case. So it does that somehow. It provides a little bit of a voltage, and I'm actually not sure if it does that via some sort of voltage regulator, or it's some sort of a passive thing where it just takes maybe there's a leach voltage. I don't know how all this stuff works, to be honest. I mean, look at all these parts here. My dad tried to explain a little bit to me how the power functionality of this actually functions. There's a PWM chip that like generates a kind of a pulse when it's on, and then that pulse kind of like makes sure that there's the correct voltage being produced that fed into the voltage regulators. Complicated stuff, which is also why this one is has a tendency to fail. There are some weak points here. There are a lot of parts that get a lot of very high voltage through them, like some diodes and resistors, and those are like major points of failure. One of those chips that like is kind of part of, I think the PWM chip was the one that was broken on this one previously, so I had to source that. Anyway, I'm kind of glad to be rid of this one. Really, these old voltage or power supplies, they're just so flaky. I mean, I guess they did the best they could, or maybe they're made to cost. I don't know. For whatever reason, they are a weak point on these old machines. So it's very nice to be able to have a modern replacement that has as few parts as possible, and will hopefully have a much lower tendency to fail. So yeah, as I said, well, I don't know if I did, when I actually got this made, I got 4 other ones, because that's when you make PCBs, the minimum order amount is 5. That's just how it works. So I have 4 more, and I don't know if I'm going to put those up for sale or something. I don't know if anyone is going to bother to go with my specific version with the extra additions, because I think most people would be a little bit annoyed by the tiny choice that I made for no logical reason whatsoever, other than I just don't like to use a part that has way more functionality than is absolutely strictly necessary. Yeah, but I guess I could put out the code for the tiny. It's a very tiny modification of the original one, and put this one up for sale, and maybe an explanation of the parts you need to buy to get this to work, and then for other people could get their little thing replaced, and maybe I'll even, I'm not sure. It might be worth selling this just for parts if someone wants to actually repair their own stock original and they want to keep it original, and they just need some parts off of this. There is I mean, the majority of parts on this still work. I'm actually, yeah, this time I never figured out. I didn't even bother looking into what actually broke. So I don't know what broke this time, but presumably the vast majority of the stuff works. I think the stuff that broke was kind of like related to the soft power, or not the soft power, the power on circuit. Lots of flaky stuff on that path, but the rest should be fine. Anyway, that's enough. Time to program the tiny, reassemble the power supply, stick it into the 20F, and do a smoke test, see if everything works. Actually, I should probably stick this into the wall just to see if it works by its own, because it should. This will provide some power to this, and well, since there is no LED on this, I guess the only way to test if it actually works, I mean, if it doesn't blow up, then that's a good sign, right? And if it doesn't blow up, then the next thing is to actually test the voltages on this thing. But that's not really going to be easy, and I'm always leery of, oh yeah, I need to clean this, lots of flux here. Yeah, I'm kind of like wary of trying to test voltages on these small pins, because it's very easy to accidentally bleach 2 of them, and then yeah, it's basically game over. Then again, I'm pretty sure this thing has some protection built in, so it will shut off. Of course, I also have this, but yeah, best not to break anything. I'll report back. Yep, so as I feared, I actually made a few mistakes printing this, quite a few expensive mistakes. So let me see if I remember all the mistakes that I made. Yeah, so first of all, this is where the AC to DC converter is supposed to be inserted. Now, when I downloaded the schematics, or the kind of the model for this, I don't think the inputs and outputs were labeled, so I just assumed the one with the big hole would be the AC input, and the DC input would be the smaller holes. But unfortunately, that turned out not to be the case. It's actually the other way around. Now, this is symmetric, so if the pins out of the little units were the same size, you could just turn it around and insert it as you will. That was unfortunately not the case. There's a reason why these are bigger. The DC voltage outputs are actually larger pins. So while you can turn this around and these will fit in here, these two would not fit in here. So what I did was just I tried to flow enough solder through these holes so that they would kind of like rest on this and stick. Hopefully it's stable. I don't know. It seems to work. Now, another mistake that I made was I somehow switched around the polarity here, so the fan would not spin. Now that was also a relatively easy fix. I just took the little pins out of the connector and I turned them around. Now another more annoying mistake was that somehow the little model for this ATtiny that I had downloaded was not the correct one. It's actually, this is too small for the ATtiny. So what I had to do was I had to squish together the the legs of the ATtiny so that it could actually like, I could easily, or semi-easily actually, solder them on. That worked out. And then it turned out that I had made a last mistake, which was in the code for the ATtiny, I had switched around the pin that's supposed to control the power on off by the button on the machine, and the OS, the Towns OS, also has a pin where it can turn on the power supply on and off. So I had switched those two around. So I had to first of all figure that out, and then I had to update the code. Now the thing for the ATtiny, it came on like a USB that I could use to program it. I found out I actually can program it using on a Mac. I just had to find the right kind of a plugin. The plugin you find online is not the correct one. You have to find another one. I had to find some obscure thread on the internet that at the bottom would mention which one to download, and once you do, now unfortunately you program it and then you have to solder it off and solder it back on here, and then I had to do the opposite way around, and somehow during that process I soldered it on backwards onto the USB. So when I plugged it in, it kind of died, so I had to get a new one of those. Yeah, also, yeah, because I had turned this around, I blew the fuse. So I had to get a new fuse. Yeah, but that's the end. The thing is, except for the turning this two around, the rest were easy fixes, more or less. So I guess this thing is still kind of useful for other people if they can live with like the fact that it's a bit janky the way you... Anyway, I updated the files for this, but there was no way I was gonna get a new print with all the updates because it would be just too expensive. So I'm just gonna have to live with the mistakes. Now I did populate this and put it into this. I assembled it. I would show it, but there is no way in hell I will take this apart again because yeah, all these plastic little things are not really held together by a screw. I think there's a single screw that holds this entire thing together. The rest is like plastic tabs, and every time you have to take this apart, you have to do it in a specific order. I always forget which order it is. I have to finagle. It's a thing. I don't want to do it ever again. It's really, and once you put it back together, it's never really quite, it doesn't seem like everything fits exactly snug. It's a nice looking machine, but I don't know about the like the construction of it. It's not optimal. Anyway, so let's take this thing for a spin. As you can see, it powers on when I push the button, and if I push the button again, it turns off. Yeah, it works. Now I haven't actually tested it by connecting it to a screen, because I don't really have a screen that's very easily accessible that I can just hook up to this. Unfortunately, back when I was doing my Japanese PC adventure, I really wanted to get a dedicated monitor for this thing, but instead I just bought an all-in-one FM Towns with a 14-inch screen, which I feel it's really too small. I really wish I had bought the 15-inch dedicated one that would go with this. It's a very neat and nice little thing. Those are super expensive and almost impossible to get a hold of right now. Not to mention that even if I do manage to get one imported from Japan, the chance of it actually making it here intact is very low. Like I don't know by what miracle I got all the other ones, but I don't want to push my luck. Maybe one day if I go to Japan and I see one for sale, maybe at Beep, maybe, or if I'm super lucky at Hard Off or something, I'll buy it and then I'll just carry it back. But yeah, never mind that for now. I did put a disc in here as a test, and it does boot it, and I can hear the game running, so it's working basically. Now, I don't really use this machine, to be honest. I use my all-in-one, and the FM Towns doesn't really have a very large library, so it's not really a machine I play a lot on anyway. So I guess this one can just go back into storage now and never get used. But if I should want to use it, it is fully functioning with a modern power supply that I can just plug into the wall here in Europe with 220 volts, and everything just works. So that's pretty neat, Yeah, so I shared the files, the updated one, on, I think it's on NFG forums. If you go into the FM Towns section there's a thread about the power supply, and somewhere there I have posted this 20F version modification of Cytoville's Cyto the Will original. So I guess if you want, you can just get a hold of his original or my updated version. Both work. I'm not sure which one is cheaper to get. This module here, it's kind of pricey, but then again, not that much. I think I got it had a pretty nice price I gave for this. And then there is the 12 volts to the Pico PSU that goes in here. That can be a little bit pricey, but I think I got a refurbished one from somewhere, so that wasn't that expensive. And some of the components you can just lift from the old power supply. Overall, I would say it's a worthwhile effort to update the power supply on these old machines. It is their weakest link, if you don't count the CD-ROM. Mine still works, the CD drive, but that one will fail at some point too, especially if people use like burnt discs, which a lot of people do. So yeah, that might be a future thing to do. I don't really need it right now, and I'm happy to keep this as is. Anyway, that's the end of this project. See you in the future.